Hello all, today in this video I am going to provide details regarding a demo video for email spam detection. Already with the same dataset we have worked with some other machine learning algorithms, and in this video we are going to work with Adaboost machine learning algorithm, and we are finally we are make an conclusion that which our machine learning algorithm is providing the better results when compared to other algorithms which we have implemented with the email spam detection dataset. This dataset I downloaded from Kaggle. If you just give like a email spam detection dataset Kaggle download means it will be just automatically downloaded. Then we initially for this we are going to import the libraries which are needed, and then our dataset. Our dataset is having nearly 3002 entries. Among this, the first 3001 entry we are going to use as the X variable, and the last variable, that is the 3002 entry prediction variable, we are using as the Y variable. And then we are checking the info of the data set, whether it is an integer, float, or string. Only one integer, that is email number, is object. All others are integers. You can notice that this integers 3001 are integers, only this one is the object type. We are also checking whether our data set is having any null entries. It is not having any null entries, so we are moving to the determination of X variable and Y variable. By using this X variable and Y variable, we are splitting our data into X train, X test, Y train, and Y test by using the test size as 0.25 and the train test split function. By this, the testing ratio will be 25% and the training ratio will be 75%, remaining 75%. Already we have worked with some other machine learning algorithms like some other algorithms. So I will just explain one by one. For that, for random forest, we have got an training accuracy of 100 and testing accuracy of 0.9737, and we have also plot an ROC curve. For the ROC curve, the y-axis is true positive rate TPR and the x-axis is false positive rate FPR. Then we have made another machine learning algorithms like SVM. For it, the training accuracy is 0.98092 and testing accuracy is 0.7710. For this also we have plot the ROC curve. Then for Naybase, the training accuracy is 0.9646 and testing accuracy is 0.9590, and we have also plot an ROC curve. Then for KNN, the training accuracy is 0.9064 and testing accuracy is 0.8708, and we have also plot an ROC curve for this. Then we have made the decision tree comparison. For this we have got the training accuracy of 100 and testing accuracy of 0.9342. We have also plot an ROC curve for this. Then for logistic regression, we have got an training accuracy of 0.9832 and testing accuracy of 0.9659, and we have also plot an ROC curve for this. Then we have worked with XgBoost and got an training accuracy of 100 and testing accuracy of 0.9806, and we have also plot an ROC curve for this. Then we have worked with Catboost. With Catboost, it will be worked with the different learning time, and it will stop its iteration once it has got some better results. So the training accuracy is 0.9997 and testing accuracy is 0.9729. For this also we have plot an ROC curve. Then we have worked with the Lightgbm, which has got a training accuracy of 100 and testing accuracy of 0.9837. We have also plot an ROC curve for this. Then we worked with the gradient boost and got an training accuracy of 0.9835 and testing accuracy of 0.9535. We have also plot an ROC curve for this. Then with this demo we are going to work with Adaboost classifier. The only difference we will be seeing within this classifier is the library function. All others are common. So for the Adaboost classifier, we are importing the library which is needed, and we are calling that classifier function within a variable, and this variable we are using with the fit function and predict function to determine the X training and testing values. For both training and testing, we are determining the confusion matrix, accuracy score, ROC, AUC curve, and also printing those values. For the obviously first the confusion matrix is there. You can notice a variation within the confusion matrix for the training variable and also the testing variable. This is due to that training variable is using nearly 75% of data and testing variable is using only 25% of data. So this only you can see a vast difference between training confusion matrix and testing confusion matrix. And also the accuracy score is 0.9716 and the ROC AUC value is 0.9969, and then the testing accuracy is 0.9543 and the testing ROC AUC curve is 0.9913. For this also we have plotted the ROC curve by using this FPR and 2PR, TPR values and by using the threshold. Then we are comparing all the models which we have declared so far, and for this we are calling all the model within a single variable called model, which is having random forest, support vector mission, naive Bayes, KNN, decision tree, logistic regression, XgBoost, Catboost, Lightgbm, gradient boost and Adaboost. This model which we are making within a loop, and within the loop we are making a training function, training the model by using the fit function and testing the model by using the predict function. We are also going to determine the value of accuracy, mean square error and R2 square error, and then we are displaying the accuracy, training accuracy and testing accuracy of every models within the single cell. So the training and testing accuracy of every models will be shown within this cell. Then we are making a table. So within this table we are making some highlight points, like the model with the least accuracy will be shown with red color and the model with the highest accuracy will be shown in green color. So you can notice that a Lightgbm is the model which is having the best accuracy and with the 0.9837, and the support vector mission is having the least accuracy with 0.7710. So after this Lightgbm, this XgBoost takes the place with an accuracy of 0.98006, and after that Catboost takes the place with 0.9729, and after that this logistic regression takes place with 0.9659 accuracy, and after that this naive Bayes takes the place with 0.9590. Before that this random forest takes the place after this Lightgbm. So this is the comparison of different models. So in the next video we will be sharing a demo video of some other algorithms, and also if you are interested in knowing some other demo video means please let us know in the comment box. So if we are aware of it means we will definitely make a video regarding it. Thank you.